afternoon. So in the last class we discussed about salt bridge. So it contains saturated solution of KCl or ammonium nitrate KNO3, and working of that salt bridge by considering electrochemical cell or galvanic cell, how the transfer of ions will take place. And after that we have studied this electrode potential. So this electrode potential is nothing but existence of a potential difference between metal and solution of its ions. Metal and solution of its ions. Why there is existence of a potential difference between these two? In these cases, there is existence of a charge separation. It doesn't have any charges, but this has, that is a particular solution has the charges. Because of this charge difference, there is the existence of a potential difference, or it is also nothing but separation of a charges that should develop that electrode potential. Electrode potential can be defined as the existence of a potential difference between two components, that one is a metal as well as solution of its ions, when there is a separation of a charges take place. According to this IUPAC system, usually this electrode potential can be expressed by considering standard reduction potential. Usually this electrode potential can be expressed by considering the reduction potential of a particular cell, because already you know that usually the cell should be made up of two components. One is oxidation half cell, second one is reduction half cell. Usually in case of IUPAC system, this electrode potential can be expressed by considering reduction half cells. Okay, so it may be noted that in the first case it has some of the important which one that consideration. The first one is the reduction potential. The reduction potential, this is nothing but reduction potential. It is nothing but a tendency to gain an electron. Tendency to gain electrons. Tendency to gain electrons. And oxidation potential. It is nothing but tendency to lose the electrons of an electrode are numerically equal in this case. Are numerically equal but have opposite signs. Second one is this reduction potential of an electrode. Reduction potential of an electrode. Reduction potential of an electrode increases with increasing concentration of ions. Right? And vice versa. The first one is usually that half cells are usually expressed in terms of there is half reduction potentials. So it may be noted that the reduction potential of an electrode, that is nothing but tendency to gain an electron and tendency to lose an electron, are arbitrarily equal. That is numerically they are equal but have opposites. Why? Because they have opposite signs. Because one will undergo oxidation, second one will undergo reduction. That is nothing but anode, it should be negative, cathode should be positive. So therefore both are numerically equal, but they have a different sign. So if it is a loss of electron takes place, that becomes a negative. If it is gain of electron takes place, it should be positive. And the second case is the reduction potential of an electrode, it will increases as the concentration of solution increases. If it is decreases, if the concentration is less in this case. So these are the two, again one more important factor for this one, how the standard electrode potential can be expressed in this case. Third one is the reduction potential of an electrode. The reduction potential of an electrode when the concentration of the solution, when the concentration of the solution is 1 molar at 298 Kelvin is called as standard reduction potential. Is called as standard reduction potential. Standard reduction potential. So it can be represented as E naught of cell or E naught of reduction. Okay, next one is the exact value of E naught cannot be determined. E naught cannot be determined. So the two important that is notification, the reduction potential of an electrode when the concentration of the solution is 1 molar at 298 Kelvin is called as standard reduction potential, and these should be represented as the E naught of a cell as well as E naught of reduction. And the exact value of E naught cannot be determined in this case. Why? This is the reason for this one is there is the existence of an equilibrium between metal as well as solution of its ions. So metal and solution of its ions, because of this one is, so the E naught of cell cannot be determined in this case. The E naught of solution cannot be determined in this case. Why it should not be? The exact value of E naught cannot be determined because of there is existence of this metal as well as metal ion. There is existence of an equilibrium between metal and solution of its ions. So the exact value of E naught cannot. So how can you determine the exact value of potential or a standard electrode potential of electron? By comparing with one of the known electrode, or it is also called as a reference electrode. Usually the reference electrode, commonly used reference electrode as standard hydrogen electrode. Standard hydrogen electrode. Standard hydrogen electrode. So this can be represented as SHE, standard electrode. So this, the reduction potential of this one is, reduction potential of this is, potential for this is 0. Okay. So this one is, this is about solution, right? Whenever 1 molar solution is taken, as well as the temperature of that system is 298 Kelvin, and that one is called a standard reduction. Instead of the solution, if you take a gas, it should be expressed in terms of a bar. 1 bar pressure should be taken, as well as the solution is same, as well as the temperature should be kept constant, and that one is called as standard reduction potential. And the exact value of this one, that E0 cannot be determined because there is existence of equilibrium between metal and solution of its ions. Therefore, this cannot be determined. So this difficulty can be overcome by considering one of the standard electrode. That one is usually called as a reference electrode. This one is called as reference electrode. Reference electrode. It is called as a reference. So by considering reference electrode, so the which one, the reduction potential of the standard electrode is 0, and you can compare one more electrode. What you want to determine? Suppose if you want to determine the standard reduction potential of a zinc, so it should be compared with the standard hydrogen, because you know the value of the standard hydrogen electrode, or in turn if talking about reduction potential of hydrogen electrode is known, so you can determine the reduction potential of a zinc. Similarly, you can determine the reduction potential of copper also by comparing that which one, copper with the hydrogen in this case. Okay. So next I will go for cell EMF of a cell. So next one is measurement of a EMF. How will you measure the EMF? Measurement of a EMF of a cell. EMF of a cell. Measurement of a EMF. When the circuit is completed, the loss of electrons occurs at the electrode. Loss of electrons occurs at the electrode having lower reduction potential. And gain of electron takes place. Gain of electrons occurs at the electrode having higher reduction potential. And difference between these two, will give the difference between these two electrodes, the difference between these two electrodes is called as EMF. That is electron diffuse. So this can be represented as EMF of cell is equal to EMF of a cathode minus EMF of a anode. So this one is about how to measure the EMF of cell. Means whenever you are comparing both, like one of the standard electrode, one standard hydrogen electrode, and you are measuring standard reduction potential of a zinc. So you should compare both the electrode. So EMF will be determined by considering a potentiometer or a voltmeter that shows a particular EMF of a cell. So you can subtract this one by considering one of the component is cathode and second component is anode. So whenever a circuit is completed, that is loss of electrons, that is nothing but oxygen occurs at the electrode that is having a lower reduction potential, and the gain of electron, that is nothing but the reduction will take place at the electrode. This will have a higher reduction potential, and the difference between these two cells is nothing but that is EMF of cell. So EMF of cell is represented EMF for cathode minus EMF of anode. So why this is more in this case? Because in this case the gain of electron will take place. This will, the reduction potential of that particular rate should be in a higher order. If you take for that anode, so anode it will undergo oxidation. It will have that it has a capacity to lose an electron. Therefore, it has a lower reduction potential. The subtraction or the difference between these two components will give the EMF of cell. So next I will go for that standard hydrogen electrode. Standard hydrogen electrode, commonly called as SHE. This is platinum 5 coated with the platinum black. This is called platinum 1. So next one is a standard hydrogen electrode. The construction as well as working of this model. So it contains a standard electrode. A standard hydrogen electrode consists of a platinum wire, and this should be sealed in a glass tube, and it should be dipped in a beaker containing a 1 molar HCl solution. At one end, the platinum wire should be that is blackened with, that is platinum black. So in order to absorb the excess of hydrogen present in the solution. And this beaker should be contain totally 1 molar HCl solution. This is nothing but it contains H plus ions in this case. Okay. So when this hydrogen gas should be continuously, it should be bubbled to the this solution. In this means this beaker should contain the excess amount of H plus ion. And that as well as in this case, the oxidation as well as reduction takes place at this, which one? The platinum 5 at this place, the oxidation as well as reduction will take place. So means it will act as an anode as well as it will act as a cathode. If SHE acts as an anode, if acts as anode, if it acts as anode, the reaction should be like this. H2, it undergoes oxidation with the liberation of 2 electrons. Or if it is SHC acts as cathode, this should be represented as 2H plus of this one, absorption of 2 plus 2 electrons. It becomes H2. Right? So this one is working as well as construction of this standard hydrogen electrode. It consists of a glass tube with a platinum wire, and this should be totally sealed in a glass tube, and this should be dipped in a beaker containing 1 molar HCl solution. And one end of this platinum wire, it should contain a platinum foil. It should be coated with a platinum black, so in order to absorb excess of hydrogen present in the solution. And continuously, the hydrogen gas should be continuously bubbled to this solution. And this foil act as, or a platinum foil act as, that is an electrode. So in this case, this will act as an anode as well as this will act as a cathode. If it acts as an anode, this will be the reaction, that is hydrogen that will liberate the 2 electrons in this case. If it acts as an anode, cathode, it should be absorbs the 2 electrons and the liberation of hydrogen gas will occur. Whatever that this excess of hydrogen that will be liberated during the reaction, this will be absorbed by, that is a platinum black in this case. Usually that cell representation can be represented as like this: platinum, it should be H2 and it should be H plus, it becomes 1 molar. It should be a gaseous condition, or it should be like reverse wise. If it is depends upon the reaction, it should be H plus 1 molar and it becomes 1 by 2 H2, it becomes gaseous and it becomes platinum. So this one is a cell representation, that is platinum, it will act as a electrode. There is a liberation of a hydrogen gas in the presence of H plus, that is H plus concentration of ion, that is nothing but 1 molar HCl solution. Or if you write this one, so it depends upon the reaction whether it undergo oxidation or whether it undergo reduction. Based on that one, you should represent the which one, a cell reaction in this case, either that one or this one in this case. So what are the limitations of this standard hydrogen electrode? This has a particular limitations of this standard hydrogen electrode. The first one is, it is difficult to maintain 1 molar concentration. It is difficult to maintain. It is difficult to maintain. It is difficult to maintain 1 molar solution. Second one is, it is difficult to maintain. It is difficult to maintain. It is difficult to maintain 1 bar pressure of hydrogen gas. And third one is the platinum foil. The platinum foil is easily get poisoned. So these are some of the limitations of standard hydrogen electrode. So it is difficult to maintain 1 molar solution. Why it is difficult? So whenever you are passing hydrogen, there should be excess of H plus ion. Therefore, there is a variation in the concentration of H plus ion. Because of this one, it is difficult to maintain 1 molar HCl solution throughout the experiment. Second one is, it is difficult to maintain 1 bar pressure of hydrogen gas in this case. And third one is, this platinum foil is easily get poisoned due to the impurities present in this solution. So these are, because of this one, these are the because of these difficulties, usually this should be avoided. Usually calomel as well as silver electrode act as a reference electrode in this case.